Hey guys, Mr. Ward, day 2 on logarithms. We spent the first day crunching some numbers as well as doing some graph theory. Let's do a quick warm-up. Should be able to do these pretty quickly. Log base 2 of 8, 2 to what power equals 8? 3. Log base 25 of 5, 25 to what power gives you 5? Square root, also known as a half. Log of 1/100th, remember that's base 10. 10 to what power makes 1/100th? 10 to the second makes 100. 10 to the negative second would make 1/100th. And this one's a tough one. Let's put this an x here, and I have 8 to the x equals 1/4. What did we say? We're going to get bases the same. 2 to the third to the x equals, what's 2 for 1/4? 2 to the negative second. 2 to the 3x equals 2 to the negative 2. 3x equals negative 2. X equals negative 2/3. Interesting. Very nice. All right. So before we go on and do some equation solving, we need some more tools in our toolbox, in particular some properties. These are ones that you should have gotten in A2, but if you didn't, no worries. The first one I call the product rule, and that says the log of any product, meaning things that are multiplied inside the argument can be broken apart. And my first thought is to multiply them together, but it's actually not. It's to add them together. Log base A of xy equals log base A of x plus log base A of y. If multiplying is addition, I'll bet you division is, you guessed it, subtraction. Log base A of x minus log base A of y. What's raising to a power to a power? I'll bet you remember that one, probably the most common. You can shoot that b out front and it becomes the leading coefficient. So b times log base A of x. These are all going to help us manipulate logarithms to help us solve equations and do things with them. All right, some simple ones. Log base anything of 1 has to equal what? 0. How come? Because anything to the 0 equals 1. What's ln of 1? Again, log base anything of 1 equals 0 because anything to the 0 equals 1. Next one. Log base anything of itself must equal 1. Why? Because anything to the first is itself. ln of e to the first. ln of e is 1 because e to the first equals e. That's going to help us a lot, both of those properties. And then ln of a to the x, well, we just learned about that, pull x out front. Or we could just say this, because a to the x equals a to the x. ln of e to the x equals x, because e to the x equals e to the x. Those three properties, sorry, I should have done that last one in green. Those three properties are going to be very useful tools in our toolbox to be able to solve some equations. All right, so we're going to practice. Let's first do some expansion. We're going to pull these apart into lots of logs. We said multiplication becomes addition, so log base 7 of x squared plus log base 7 of y. Then we can shoot that out front. So to expand it out as much as possible, log base 7 of x plus log base 7 of y. We got a division here. Log base 3 of 3 minus log base 3 of 5. And anything that can be calculated numerically. Log base anything of itself is a 1. That's it. We're getting better, getting more comfortable with this idea of a logarithm. Next one, we got a property, a couple properties actually. I think this applies all three. We're first going to say ln of x squared y minus ln of z. Then we're going to say ln of x squared plus ln of y minus ln of z. And then we're going to shoot the 2 out in front. Best answer, 2 ln of x plus ln of y minus ln of z. Keep going. Switching colors each time. See if that helps. The 3 goes out front. So 3 in front of the whole thing. Log base 4 of AB minus log base 4 of 16 equals 3. Log base 4 of A plus log base 4 of B minus numbers. Log base 4 of 16, you got it, 2. Now I could distribute through that 3 if I wanted to, depending on what I'm doing. 3 log base 4 of A plus 3 log base 4 of B minus 6. 3 times 2 is 6. I like that answer right there. Keep going. ln of e to the 4th plus ln of x cubed. Shoot it out front, or either way you slice it, 4 ln of e plus 3 ln of x. ln of e is 1, so I'm left with 4 plus 3 ln of x. And again, that's going to lead us into how to solve things, how to do stuff with these log equations. And last one, log of 5 minus log of 100. Can't do much with log of 5, but I can do something with log of 100. Log of 5 minus 2. Those would be the same thing. So we're taking logs apart. Now we're squeezing them together. Rewrite as a single logarithm. Let's apply some properties. That 2 can go up. That subtraction become division. So log base 2 of x squared minus parentheses log base 2 of yz, because addition becomes multiplication, which we can turn all into one big division. Log base 2 of x squared over yz. Sometimes to show it's all in the parentheses. That's the argument of the logarithm. All right, let's do it again. Log 1/3 ln of x plus ln of y squared. 1/3 ln of x y squared. ln of x y squared to the 1/3, also known as cubed root of x y squared. Last one of this type. Squeeze them together to a single log. Let's call this, I'm going to do 2 steps at once. Put the 3 up, turn the subtraction into division. So that would be x cubed over 10 plus, again, 2 up, 1/2 up, and division. Maybe that's too much. Log of y squared minus log of z to the 1/2, or the 0.5 power. Log x cubed over 10 plus log y squared over radical z. And now I can put it all together to a single log. Log x cubed y squared over 10 radical z. Crazy. Analysis, pulling apart. Synthesis, putting back together. Okay? They're both valuable. Depending on what we're going to do, we're going to need both skills. All right. If I know that log base x of 2 is a, the value a, log base x of 3 is the value b, and log base x of 5 is the value c, evaluate the following in terms of a, b, and c. That's the last component, which means I'm going to use my properties. Watch. Log base x of 9 minus log base x of 10. Now I need to express 9 and 10 in terms of 2's, 3's, and 5's. And I can do that. Log base x of 3 squared minus log base x of 2 times 5. Why did I do that? Because now I can apply those properties, put the 2 out front, log base x of 3 minus parentheses log base x of 2 plus log base x of 5. Now and only now can I plug the a's, b's, and c's back in. 2 log base x of 3 is now 2b minus parentheses a plus c. If you want to distribute through the negative, you can. 2b minus a minus c. Let's do it again. express 30 in terms of 2s, 3s, and 5s? Well, first thing I thought of with 30 is 6 times 5, which is better known as 2 times 3 times 5. We break them all up into addition, which means we're going to end up with A plus B plus C. All right, again, properties that are going to come in handy. Let's not do them with arbitrary letters. Rather, let's do them with some numbers. If log base x of A is that first decimal, log base x of B is the second decimal, and log base x of C is the third decimal, evaluate this. Let's pull them apart. The 2 is going to go out front of the C. And we're going to subtract from it A. Now in parentheses for the log of C, I can put this one in, 0.345 minus log A is 0.6578. I already did the calculator work, 0.0322. Again, using these properties. How can I express a radical to the 1/2? Which can become our leading coefficient, and then we can do a whole lot of plussing. Now we can plug in the decimals. I'm not going to bother doing all 3 because it just takes a little bit of time. From the 3 decimals up above, you get 1/2 times all that, 1.67445. You pause it, plug it into your calculator, make sure you understand. And then the last one, log base x of A divided by, I see division, which is going to become subtraction. Then I see multiplication down there, which is going to become addition. Now I can plug in the decimals, 0.6578 minus 2.3461 plus 0.345. If I subtract all those, I get negative 2.03 repeating. All right, that doesn't look like a 3. Now it does. All right, about 12.5 minutes. We got about a minute and a half left. We can get these last couple done. Use log properties to simplify. Log base 5 of 50 is also known as log base 5 of 50 to the 1/2, which we can shoot out front. We can call 55 times 10, which is log 1/2 log base 5 of itself plus log base 5 of 10. 1/2 1 plus log base 5 of 10, which is 1/2 plus 1/2 log base 5 of 10. All right, next one. Let's pull it apart. ln of 2 plus ln of e to the 4th, ln of 2 plus 4 ln of e, ln of 2 plus ln of e. Next one. Kind of rushing through. Got a little bit less than a minute, but we got this. Log base 2 of 16 plus log base 2 of x equals 2 to what power equals 16? You got it, 4 plus log base 2 of x. We are simplifying. And finally, ln of 6 minus ln of e cubed, ln of 6 minus, take that shortcut, call it 3. Actually, I did mess up here. I was thinking about that for a second as I did it. That 10 could now become 5 and a 2, which is another 1 plus another 1/2. So the best answer for that is 1 plus 1/2 log base 5 of 2. That's the best answer. Sorry about that. But again, pause these, take a look at them, make sure you understand everything. Log properties, day 2. Well done. Have a good day, folks.